You're sitting at a drafting table in a sunlit engineering classroom, pencils, rulers, and a bulky 90s computer with AutoCAD Release II humming quietly. James Earle guides you through translating wild ideas into crisp, precise lines. But here's the kicker, it's not just about drawing. There's a hidden rhythm to these graphics, a mix of creativity and cold logic that shapes everything engineers build. How do you turn that jumble in your head into a perfect blueprint? Let's crack that code. Imagine transforming a messy hand-drawn sketch into a flawless digital design, not by magic, but by mastering tools and principles that feel like second nature. Bob Jensen, a student from Colorado State University, struggled to get his water pump design right on paper, messy dimensions, inconsistent lines. With Earle's step-by-step AutoCAD Release II examples, Bob learned to digitize his concepts with exact measurements and clean layers. Suddenly, his chaotic sketches transformed into a professional-grade blueprint, impressing his professors and accelerating his project timeline. Think of AutoCAD as a master sculptor's chisel, but for lines and angles. Earle compares its tools to a laser-guided Swiss Army knife slicing through guesswork. Every click adjusts an object with pinpoint accuracy, saving hours of manual correction. This mechanism turns spatial chaos into order, giving you the confidence to explore wildly creative solutions without fear of messy redos. Once you grasp these foundational skills, the real payoff emerges: creative freedom. Earle reveals that knowing how to control your digital canvas lets your brain focus on inventing, not erasing mistakes. The surprise: constraints of technical standards actually fuel creativity. Like jazz musicians thriving within chord structures, engineers innovate best when they know the rules inside out. Engineering drawings aren't private journals, they're universal instructions. But how do standards turn diverse minds and messy hands into a shared language everyone reads perfectly? In 1986, a bridge project in Indiana faced near collapse due to misread blueprints. James Earle points to ANSI, American National Standards Institute standards, as the life-saving grammar behind clear engineering communication. The team realigned their drawings with these standards, preventing costly errors and unsafe conditions, proof that a shared visual language can be the difference between disaster and success. Earle likens these standards to grammar rules in language. Without commas and periods, sentences confuse and readers stumble. In engineering graphics, dimension lines, symbols, and projection methods serve as syntax. Like readers instinctively understanding a well-punctuated sentence, fellow engineers instantly decode blueprints when standards are obeyed, slashing mistakes and speeding approvals. The payoff: when designs speak the same language, teams sync effortlessly. Earle highlights that this ultimate hack lets global engineering teams collaborate, whether in Detroit, Delhi, or Dubai. It's the secret tech behind massive projects and fast innovation cycles. Mastering standards means your drawings become clear instructions, not puzzles. What if your drawings could jump off paper and live in 3D inside your mind? Spatial analysis is that skill, seeing parts, shapes, and twists before any tool touches metal. Maria Lopez, a student at MIT, faced a gnarly challenge: designing gears with complex tooth interaction. Earle's exercises pushed her to visualize gear mechanisms mentally, simulating rotations and interference. Once Maria saw these interactions without drawing every detail, she caught errors early, saving weeks of trial and error in the workshop. Earle describes spatial analysis like origami, folding a simple sheet into a complex crane. Instead of paper, you fold and rotate geometric shapes in your mind, anticipating how parts snap and slide together. This mental practice prepares you to troubleshoot before machines hum or materials cut, weaving foresight into every line you draw. After mastering spatial skills, you stop being a passive drawer and become an active problem solver. Earle's insight: this mental shift makes design smarter and faster because you're not just sketching, you're anticipating real-world physics. Suddenly, errors shrink and creativity expands because you're working with your brain's 3D superpower. Remember Bob at his drafting table? That chaotic sketch wouldn't survive without the clear standards and spatial smarts Earle breaks down. When you combine precise digital tools, universal language, and 3D mental models, you become a design wizard, transforming ideas into build-ready realities. Next time you sketch, try pausing to fold your design in your mind before drawing the first line. You'll catch mistakes before they happen. Subscribe for more book summaries like this one.